Good morning. Welcome to your last FOR 242 lecture. So, one part of this is going to be how the final exam is going to work. The final exam will be practical. The second part is a high-level overview of what I hope that you have gotten out of this course. So, first part, you're probably jumping at the bit to know, is the final exam, practical exam. In the past, it has been the 2-hour block. That's what you get. And start to finish with all resources, because nobody practices GIS in isolation or in a bubble. I want you to have your resources and be able to interpret them, use them, and combine them into a product that is useful. So it is open book, it is open note, it is open YouTube, it is open internet, because if you know any computer programmers, if you know any GIS people, they're constantly Googling things. A person who is a professional GIS user or a professional programmer is a person who is supremely good at acquiring and utilizing information. And that means that, one, yeah, you have your notebook. I don't have it with me here because I'm at home, but I have a little red notebook that contains all of the really cool things that I figured out how to do. And there's videos on my YouTube channel that are literally just me talking to myself, reminding myself how to do some particular step that is particularly difficult. Because I don't remember these things. I figure out how to do it. I either write it down or I record myself doing it so I can go back. Oh yeah, I did that last year. That's how that works. So I'll go ahead and do that again with modification or just repeating the analysis. So those kinds of notes are good and useful and something you develop over time as you use GIS professionally. And you do, because in the modern forest profession, whether you're an operator in a skidder or a grader or processor, or whether you're the forester directing those machines in their operation, you are using GIS to communicate. That could be through Avenza Maps, meaning you produce a map and then you export that map and give it to somebody else. It could be a printed map where you do the same thing and hit print, or it could be an online GIS interface. In any case, it's as important, or maybe more important, than being literate, being able to read and write clearly to communicate your instructions to somebody else. So that's one of the fundamental points of what I hope has come through in this class, is that LiDAR and GIS, but mostly GIS, has been around for 20-ish years in its modern-ish form. It's become very important. But LiDAR is a whole nother corner of that is becoming critically important to forestry. And that's one of the things that I've hoped that you've gotten out of this. But so the final exam, because there's been so much fun and games with connections, I'm not making this a timed 2-hour proctored thing. There's pretty well no way to cheat on this besides asking each other what to do, and I depend on your honor to not do that. Everything else is open book, fair game. If you search YouTube, find videos you've used before, or videos that you haven't used, that would be a waste of time, but I'm going to be asking you to repeat analyses that are within the scope of what we've done in this project, in this course so far. So what you should do is review all of those things that you've done so far and remind yourself where the resources are that you need to be able to reproduce those analyses. So for example, if you look at the past assignments, so yeah, we did a terrain profile graph on this one. If I need to make a terrain profile graph, here's the video that I will use to remind myself how to do that. So I would suggest that starting right now, you go through and catalog the videos, bookmark them, remind yourself where those are, so that if you need them in a pinch, like an exam, you have them right there to go. But I said it's not going to be a timed 2-hour thing, it's going to be a 1-day thing. So it's going to be Tuesday, May the 5th, starting beginning of day and ending end of day. And that's because I expect things to go wrong with connections and internet and Wi-Fi and all of that. And if things go drastically wrong and your internet cuts out for that entire day, let me know and we'll work something out. But that's going to be a whole day, open book, open resource thing, where I strongly recommend you begin cataloging those resources that you need to replicate essentially every analysis you've done since the midterm. So That is the structure of that. It's going to be an exercise, not very much unlike what you've been doing, but combining those things into one product. So what I hope you've gotten out of this course is that LiDAR, light detection and ranging, if you're talking to a European, they'll call it airborne laser scanning, is fundamentally changing the way that forestry is practiced. It's changing the way you do your field work. It's changing the nature of that work, where in the past you would have spent hours to days thrashing around in the brush, trying to figure out where the perennial stream becomes the ephemeral stream that drains less than 300 acres and doesn't meet regulatory thresholds or meets different regulatory thresholds, and then putting a 75-foot buffer on this part and making sure channel integrity is protected on that part. Nowadays, you can find out exactly where that stream channel ought to be, and then you can put a buffer around that on the computer and then go walk that line. So instead of going back and forth, back and forth, back and forth, you can walk the stream channel, make sure the stream channel is where it belongs, and if the actual location of the stream channel matches the calculated location of the stream channel, the buffer that you created is ready to go. And that cuts down the work tremendously. So instead of going out and finding the stream, you're confirming it. And if the stream is confirmed, then you can put that buffer on and job done. Looking at LiDAR, you can find vernal pools. You can find areas of interior habitat, like looking at this. That is a huge patch of interior habitat that you can look at and see. If you ran the analysis, you would find that because there's no big gaps. The roads all end here. You can interpret the width of the road, that line there, old overgrown road, old overgrown road. Don't try to drive on that unless you have massive tires and a lot of money to burn. You can look at the integrity of the buffers around ponds. There's that big buffer around those ponds, should be 250 feet. If you want to know exactly what it is, just like that, you can measure from the pond's edge to there. Looks like it might even get out to well beyond that minimum 250 feet, might even get out to 500. Maybe that's what that one gets. You can see the boundaries between ownerships, where this owner has done some harvesting up to here, and this owner has built roads to get into here but has not yet. Or if we zoom in, we might see that they've done some lighter management. I don't see any skid trails popping out at me there, but you never know. But the management is fundamentally different between those two owners, and you can see that boundary line there. You can see recent clear cuts, less recent clear cuts. Those are the ponds, these are the roads. You can interpret a lot about this forest without ever setting foot on it, provided that you have recent reliable LiDAR data. This is from 2017, it's 3 years old. The owner that built the roads here may have since concluded the operations these roads were built for. So this picture will have changed. But you can measure the wood products, you can interpret whether this has hardwood or softwood using air photos, and then estimate whether this is a high, medium, or low volume stand based on the height and the width of crowns. Or if you have the metrics calculated, you can have those things ready to go in those grid cells you saw from Irving. So it is making it possible to rapidly measure a complete inventory, where before you would have a series of cruise points that would have to represent this whole. Now you have the whole, and it is measured with the lasers, and that is a snapshot in time. That's understood, that you have to take change into account when you consider these things. You have to update these areas and your assumptions about them when you know that has been harvested since that flight. But it is fundamentally changing the way we do inventory, the way we do planning, the way roads are planned, because you can see with extraordinary precision the land itself and how you might lay a road across that land. You'll have much more on that with Jeff Dubas in his road building class. You can estimate habitat values. You can look at the height of trees. You can look at trees that are in isolation above the canopy, the super canopy white pine that can be used for a hawk's or an eagle's nest. You can look at the size, integrity, depth of the buffer around ponds or streams. You can look at the amount of cover over streams that give them shade. You can look at forest interior, you can look at forest edge, you can look at gaps, you can look at anything that could be seen here. dense forest, more open forest with regeneration, patch cuts. Measure the size of the patch cut really fast. How big is that patch cut? 500 feet across that way, 388 feet across that way. What is the height of the surrounding forest? 20 meters, about 60 feet. So that's a 10 tree height wide gap, 600 feet across. Trees are 60 feet tall, 10 tree height gap. That is something that you can measure without ever setting foot on that ground. So everything has changed about the way we do inventory with this in mind. If you want to do a classical forest inventory, you are so much better off to draw your stand boundaries based on the height of trees. That you could look at this area right here and say, oh, well, this is all maybe one block. Absolutely not. This is different from this and has got to be treated so. These little inclusions of shorter forest, if your inventory plots happen to fall here, 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 and here, and missed these, you would drastically underestimate the volume. It does not tell you everything. It does not give you an answer, but it allows you to interpret a lot more than you would have from a simple air photo. And there's a bog, and bogs are cool. So all of these things you can interpret in the field and interpret in the lab or in the office, and then go out and confirm in the field. You are still obligated to go out on the ground, look at everything. That is your responsibility as a forester. But you can make these interpretations, you can make these predictions and projections, and find out what you expect to find. And with that expectation in mind, you can confirm that it is as it is or it is different. Clearly a regenerating situation, pond regeneration buffer. You can also measure recreational attributes. The value of the terrain profile. Well, it's good for measuring the steepness of a potential skid trail or a potential road. If you make a road too steep that a loaded truck can't get up when it's icy, that's a problem. Terrain profile graph can help you make that call. Make sure that your road is going within the grades. It can tell you where to say, I need to bring in some fill and build this road up so it's not too steep. We're not going down too much in that depression. You can do any number of things with that, but the terrain profile graph is also tremendously useful for recreational trails. You want to go for a hike, you want to know, all right, it's going to be this steep for here, and I'm going to get to here and it's going to go like that for a while. If you're working search and rescue and you know there's a person hurt at this location right here, and you are here, draw a line from point A to point B, you can see how steep the ground is going to be between point A and point B, just like that. And let's demonstrate here. So let's turn off our canopy height model. There's our digital elevation model. Let's say that I am right here, and there's somebody hurt here. I can tell it to look at the digital elevation model. I can draw a line from where I am to where the injured person is. I can create a terrain profile graph, and I can see this is a straight slope from me to them with no major issues in between. If I did that same thing and found a steep ravine in between here and there, I would have to reevaluate that course so that I did not end up dragging a stretcher across that. So there is a definite advantage to being able to do that just that quickly. Within 30 seconds, I can look at the entire route that I'm about to take that I've never been on before and make the judgment, is this going to be a practical route or is it not? So values for recreation. How steep is this trail? Is it within my ability? Within search and rescue, if I need to get to this person and drag them back, can that be done safely, or do I need to go around some kind of an obstacle? All of these things come from actual measurements of the ground using lasers, which is massively better than how it was done 50 years ago with a stereoscopic image, looking down at it like that and drawing contour lines. They were tremendously good at that. That is a valuable resource. It's impressive what they were able to do with the technology they had. But it doesn't show you everything. In the way that LiDAR, if it is flown properly and the data are good, it does not show you that level of detail, and that is the extraordinary advantage of LiDAR. So let's see, recreational attributes, habitat values, wood products. So the whole range of things that foresters are responsible for, every bit of that is touched in some way by LiDAR or can be improved in some way by LiDAR. You can count on using this in your careers, whether you're on the receiving end of maps as an operator or the producing end of maps as a forester, or if you go to work in a park or for any other thing. This is a technology that you will see. And I hope you've had a good introduction to this. The computing situation with the remote connection has been an adventure, but that again is something that is valuable to know how to do. That in the real world you have to use these tools. It's not something that I would normally build into a course, but the fact that you have now got experience with remote desktop connections is valuable. So when you're in the real world, you are likely to have to make that kind of a connection to access a work computer that's sitting in an office somewhere from a personal laptop or something. That's something that happens a lot. Something that I've always had my computer set up to be able to do that, so that if I'm sitting in Hawaii, I've never been to Hawaii, but if I was, and I desperately needed to access my office computer to get some file for somebody, I can do that like that, no matter where I am in the world. No matter what computer I log into, I can find a way to get into that with the proper connections. So that is valuable, even though it's been a bit of a pain. So we have the final exam coming up. It is on Tuesday the 5th. I hope we're clear on what it is you need to do, how you need to prepare for that. Ask me any questions you have, and I will see you in the fall, and I'm going to be teaching you how to run chainsaws, so I look forward to that. And until then, stay safe, have a great summer as best as can be done, and I will see you soon.